welcome to my talk. By the way, this is the topic of the talk. If that's not the talk you were coming to, we had to switch of rooms, and so this is your chance to get out. But you're also welcome to stay if that's something that could also interest you. So to give you a little background, why I'm doing this talk today, where I'm coming from. My name is Jonathan Bregler. I work as a developer for SAP. I'm based in their headquarters in Waldorf, Germany. And I'm part of the SAP HANA database development organization. And so lately I've been working mostly in the area of developer tooling, developer experience, these kinds of things, and always related to SAP HANA. So just a quick question for you. Do you know the term Translytical that I used in the title of my talk? Anybody heard of it? No. All right, good. Glad I prepared a slide for that. So what is Translytical? Well, Translytical means it's a combination of transactional and analytical. There's another term for it called HTAP, Hybrid Transactional Analytical Processing. So if you heard that, that's basically the same thing. And so a translytical system is a system that can process multiple types of workloads, so analytical, transactional, operational, simultaneously in real time. So the question is, why do I care about translytical workloads? What's the benefit of that? So typically in an organization, you have systems that process transactional data. So that's your operational system that collects things like sales orders or have your inventory or whatnot. And then you usually replicate the data into an analytical system like a data warehouse or a data mart and do reporting on that to get insights in your data. And so with a translytical system, you can do all of that inside one system. And that has several benefits. The most obvious one is you don't need a separate analytical system. So you save money on that alone. And also, there's only one copy of the data that you do your operations on. And I'm sure all of you know, as soon as you have two copies of the data, you'll also end up with two different copies of the data because you'll end up with inconsistencies. And so having one copy of the data and doing all the processing in one data eliminates that. Also, the replication itself can be a problem because it takes time. Depending on the amount of data and the frequency where you can run it, your data that you run the analytical workloads on can lag behind hours or even days. And so the insights you get are always a little behind your actual situation. And that's also what a translytical system can help you with. And so the question is, why do I care personally? Why do I deal with translytical systems? Well, guess what? SAP HANA is a translytical system. And so it is a translytical in-memory data platform. So what does that mean? Well, like I just said, it can handle analytical and transactional workloads at the same time. And it's an in-memory system, which means all data is stored in memory. So there's no disk-based accesses. And at its core, HANA is a typical relational SQL data store, so you can use it as a general database, drop-in replacement for pretty much any SQL database. But it's much more. So like I said, one is it's in memory, so it's really fast. The other one is the relational data store is organized in a columnar way instead of the typical row-wise. And it turns out that columnar organization lends it very well for running analytical workloads because analytical workloads usually involve aggregations on columns. So get the sum of all sales in a quarter or get the average volume of a sale, something like that. It's not only a SQL data store. There's much more to HANA. It also comes, for example, with a JSON document store. So you can run NoSQL workloads. It has a geospatial engine, so you can process geospatial data. It has a graph engine, so you can run graph algorithms natively in the database. It has full text search and text analysis capabilities. So that's something what you usually would need, for example, a separate Elasticsearch instance for, so you can do that also right in the database. And it also comes with a whole range of predictive analytics algorithms, so you can also run predictive or machine learning algorithms on the data. Also, there are data federation capabilities, so you can not only access the data that's located inside the HANA database, but also access external data in other databases or generally other data sources. All right, so that's the background where I'm coming from. And So over the past few months, we've been working on a proof of concept for an R2DBC driver for SAP HANA. So first, I want to talk a little bit about reactive programming in general. So who of you knows what reactive programming is or has a rough idea? Good, that's almost everybody. And I guess you went to some of the other talks about reactive programming like I did, so they were really useful. So I'm just going to touch really quick on the concepts behind reactive programming. And that usually includes things like it's non-blocking as a fundamental concept. So operations don't block for example, I/O, be it file-based I/O or network I/O or database I/O. It's usually asynchronous because that further increases the efficiency of the entire system. It's a declarative approach to programming. So it's more like functional programming. You define what you want, not so much the how and the when. It's designed to be resilient, which means in error situations, the errors are handled gracefully and only affect parts of the system and don't tear down your entire system. And there's also the concept of back pressure, which means a receiver of some data can inform the sender that it can process the data only at a certain rate, or it's about to be overwhelmed, and it can throttle the rate at which the sender sends the information. Let's dive a little bit into the declarative approach that reactive programming uses. So this is a code sample. If it's written like this, you can read it. So it's ConnectionFactory. You create a connection from it. From the connection, you create a statement, and you execute it and do something with the result. But being a reactive piece of code, so the ConnectionFactory doesn't actually create a connection, but it rather creates a publisher of connections. And then you can subscribe to that flux that's emitted by that and do operations on whatever gets emitted by that. And so what this piece of code then does, it takes whatever connection comes out of that publisher and creates a statement from it. And then it executes that statement, and the execution itself will return, again, a publisher of results. And then you take the publisher of results and connect to that. And for each result, you call a map method, which internally creates another flow of rows. And then for each of those rows, you extract the value of a certain column as an object. And so this is basically the execution graph that gets created by this piece of code. And since it's reactive, there's also back pressure possible in all of those stages. To limit the rate at which the individual objects are processed. And so one important thing to notice here is that this piece of code actually just generates the execution graph. It does not actually execute it. And because in reactive systems, nothing happens until you subscribe to such a publisher. Right, important to notice. So let's see, let's assume we have a reactive program, a reactive application, and want to do database access. So how do we do that? Well, naively, if I'm programming in Java, I'm just going to say, well, I'm just going to use JDBC because that's the default in Java. Well, unfortunately, it turns out that's not really a good idea if you're doing reactive programming because we can check how JDBC applies to those reactive concepts. So is it non-blocking? No, it's completely blocking. Is it asynchronous? No, completely synchronous. Is it declarative? Nope, imperative. Is it resilient? Well, not really. Each method call can theoretically tear down your application. And does it support back pressure? No, obviously not. So what does that mean? If you use JDBC in your reactive application, that means you might as well not do reactive programming. Because all your application is going to do is going to block on the JDBC calls, and the rest of your application may be as reactive as it wants to be. It just won't make any difference. So what do we do now? Well, that's exactly the situation where R2DBC comes in. So what is R2DBC? Well, R2DBC stands for Reactive Relational Database Connectivity, and it was explicitly designed for database connectivity in reactive systems. So I'm just going to real quick recap the design principles that were also highlighted in Mark Pollock's talk yesterday. So the design principles behind R2DBC are it embraces reactive types and patterns. So it's a natural fit for reactive applications. It's non-blocking all the way to the database, so you get the benefits of reactive programming. It has a documented specification, so it's clear what it does. And the driver SPI is really shrunk down compared to JDBC, which means only the parts that really relate to the database, that are database specific, are implemented by the driver developers, which is also different from JDBC that has both parts that are specific to the database and also parts that are specific to more like application programming. And the idea is that on top of these drivers, there can be multiple humane APIs that can be used from applications then, like, for example, Spring Data, R2DBC. All right. I'm just quickly going to show you the main components of R2DBC so you get an idea. So like before, you usually start at a ConnectionFactory, and you call the create method. And like I said before, then you get a publisher of connections. Typically, that only publishes one connection, but at least the signature doesn't really specify that. The connection looks like this. It's pretty standard. If you look at it, you can immediately understand what the methods do. There's lots of transaction handling, so starting transactions, committing, rolling back, creating save points. There's some methods for getting connection status, like is it in auto commit mode, what's the isolation level. And also there's methods for creating statements, so either statement batches, multiple statements, or single statements. And as you can see here, most of the methods' return values are actually reactive stream types. And the statement also looks pretty standard. There's nothing surprising. There's bind methods for binding parameters if your statement supports that. There's an execute method that can return results. And there's some more methods for adding multiple batches of parameter values and returning generated values from the database and setting the fetch size. So far, so good. That's definitely not all there is to R2DBC. It's just the most important parts. If you're interested in all the details, go to the R2DBC website and look through the code, and then you can see everything. OK, like I said, we've been working on implementing a proof of concept for an R2DBC driver for HANA. And so I want to touch on some of the things that we faced while implementing it. So first of all, looking at R2DBC, it's a really simple API. There's not too much to implement. So you might think, well, I got some free time on the weekend. I'm just going to sit down and write a new driver from my favorite database. And about a few hours in, you'll realize, oh, wait, there's lots more that I need to implement. Two things I want to highlight is type conversions and the actual database protocol. Type conversions you can have on two levels. One is since you operate on the database wire level protocol, you need to convert the wire representation of a type to some Java object. And so first you need to figure out which database type could fit which Java object, and then how to really serialize that onto the stream and get it back from it. And then another one could be that you need to convert between different Java types. I think that's not strictly required by the spec, but for example, if you have a decimal type on the database and you decide to use big decimal as the default Java type for it, your application might still, for example, want that value as a double, as a float, as a string, as maybe an int. So you need to think about these types too. And then there's the more complicated ones, like how do I convert the wire representation of a spatial geometry to a Java string? And so depending on what your database supports, you have to do a lot of conversions. The database network protocol itself, depending on your database, might be more or less complicated. And so you need to first understand what the different parts do, and then also build an implementation so you can read and write those from the network. Another minor issue, the API of R2DBC, R2DBC being a relatively new project, is still evolving. So from time to time, there are changes, and so you need to adapt little things. But it's usually not really big things, and it should stabilize over time as it gets more mature. Another lesson is database level documentation is pretty important, especially if you implement the protocol. So because protocols are usually not really intuitive, and without documentation, you're pretty much stranded. And One thing is there's also a difference between the documentation is there and the documentation is complete. Because so, for example, one thing I noticed when I started implementing it, so first it says, well, you have to initialize the communication. And there's a section in that in the documentation, and it even has like the image. And so apparently there's a client, there's a server, and so I'm supposed to send an initialization request and get back an initialization reply. Easy enough. So I sat down to implement it, and I was like, oh wait, what should that initialization request even look like? And lo and behold, it was never mentioned in the documentation. So I got stuck at the very beginning. And so, I mean, I could have asked some of the developers who had already done that. But I thought, well, I like doing things by myself and learning something. So eventually, I found an existing open source driver that was written in Python, available on GitHub. And that actually had that initialization request already implemented. And so I just took it from there, and then I was able to continue. So remember, if there's open source drivers, that's a good resource for figuring out things that are missing in the documentation, also to get implementation hints. Then, like I mentioned, if you've not really worked with reactive programming before, it's different and might not really do what you want. So question, what does that do? I'm just going to answer for you. It does nothing. Because it's basically the situation that I described before. This just builds an execution graph. Although it has a subscribe in the middle, what's missing? There's no subscribe at the end. And so I actually wrote this piece of code. It's supposed to send a disconnect request to the database right before you shut down the connection. And so I wrote a test for it. And I was very disappointed that no disconnect request was ever sent. So I started debugging, and the debugger came across this code and apparently executed it, but still nothing happened. And so it took me a while, but eventually I figured out, well, you need to subscribe. OK, there you go. Also, if you're not used to reactive programming, there's lots of new API to learn. It starts out simple. Project Reactor gives you basically two types of publishers, Mono and Flux. And you say, well, Mono just emits 0, 1 items. Flux can emit multiple items. Oh, good, I'm all set. Let's just use them. And then you look at the API, and you're hit with just a truckload of methods. And then you're lost again. And it really doesn't help that most or many of them sound like they do the same. So what's the difference between map and flat map memi, and flat map sequential, and flat map iterable, and concat map? And those all kind of sound the same. But of course, there's subtle differences. And so there's a high chance you just select the wrong one. Anyway, so this is something you need to deal with. Another thing, if you work for a big company, there are usually policies that get in your way or that are supposed to guide you to making the right decision. So for example, open source software. R2DBC is open source. They're open source drivers. So an intuitive choice would be, well, I'm just going to write my driver and publish it as open source. But then again, if you do that in a company, they might not like that. And so they might have processes in place that you have to go through, or they might plain say, no, we don't do open source. So that might be something. Also, security. Usually, if you deliver software, there are export restrictions, especially if you use cryptography. For example, for establishing secure connections to the database. So you need to take care of that. Also, customers might expect certain features from a driver that's delivered by a company that, for example, exposes database-specific functionality that's not really covered by the R2DBC spec. And so the question is, can you deliver a driver that just works as an R2DBC driver, or do you have to really create all this additional functionality before you can deliver it? And of course, if you release a driver, you also have to support it as a company, so you need to plan for that and allocate some resources, especially if it's just released, because bug-free software doesn't exist. We all know that. And so if you ever ask me what's the status of the driver, of the R2DBC driver for HANA, I'm probably going to tell you it's stuck between implementation and this slide until it's actually released. Then we made it through. OK, so until now, I've highlighted mostly problems, but actually, it's not all that bad. For example, as far as reactive programming is concerned, the initial learning curve is steep, but so one thing is it gets easier over time. As you get used to it, you make better decisions, what to call, how to combine the different operators. And also what I like is that the API documentation of Project Reactor is really good. So here's an example that's for the flatmap iterable method. And so it doesn't only have the textual representation of what it does, but most methods also have like a little picture that show you graphically what happens. And that makes it really easy to understand and also to compare different methods, because the pictures will be slightly different and you can see where the actual differences are. Also, there's an entire documentation section on which operator you should use, so you can always turn to that. Also, while an R2DBC driver requires a lot of base functionality, so working protocol implementation and type conversions, once you have that minimum set of features built, then it gets really fun. Because then once you can talk to the database, you just implement a little bit of more functionality, then you immediately get the results back, and then you get the free endorphins from your brain, and then you add some more, and then you see more happening, and so then the iteration gets really fun. Also, you don't have to reinvent the wheel. There's resources out there. If you get started on a driver, don't start from scratch. Use one of the existing open source drivers as a template, and just adapt what's needed to fit your database. And also, the R2DBC team can help you if you have questions. So there's a mailing list, there's an email address, there's a Twitter account, and there's even a status call once a month that you can join if you want to ask questions in person. Okay, so just to show you the status of our proof of concept, where we are right now. What we've done is we've defined the format of the protocol that we want to use. We've implemented the most important protocol parts so we can actually interact with the database. We've implemented the most basic type conversions so we can actually get stuff back and convert it to Java objects. We can log in and authenticate to the database. We can create queries, both direct and prepared queries. And we can extract the results of those queries via the result sets. What we still need to do is some of the protocol parts are missing, mostly the optional ones for supportability, but also for features that we just haven't implemented yet. Some of the more complicated type conversions are missing, for example, like the spatial types. I don't know yet how we're going to expose those. Procedure calls we haven't really tackled yet because on that the specification is also still in flux, so they're still working on how procedure calls should look like. So we kind of want to wait that out. And there are a few minor things like I need to look over commit handling, so just setting the auto commit status. Query batching I haven't really implemented yet. Getting auto-generated values from the database. And once we've completed all that, of course, we need to do thorough performance testing to make sure what we've implemented is actually usable and makes the performance better than just leaving your application as is. Okay, so summary. Reactive programming is gaining traction. And as reactive programming becomes more popular, also the need for access to relational databases will rise. And database vendors have to think about what they want to do to support these kind of applications. In my opinion, R2DBC is a promising effort to fill that gap between reactive applications and relational databases. And I can just encourage you to give R2DBC a try. Either use it in your applications, or if you find bugs or missing features in the existing drivers, contribute back. Or if you find there is no driver for your favorite database, you could always try and implement an entire driver. So, and even if it doesn't work out, it's always a fun exercise. All right, that brings me to the end. And I think we have like 3 minutes for questions if you have any, and if not, then thanks for listening. Yes?
Do you have to do anything special with the server configuration system, WebSockets or
The question is, do we have to do anything on the server side? I'm pretty sure to make it work better, there are also changes necessary on the server side. but so far we haven't really looked at that. But I'm pretty sure there's optimizations you can do as well. Yes?
So can you give us a sense of how much effort was involved and how much is still left from a number of, ballpark number of man months? Or I know this is just POC, but I'm just curious how long. So if you're thinking about implementing an R2DBC driver, how long is kind of a ballpark? I know there's probably a lot of variables depending on the type of database and what the protocol looks like, but I'm just would like to get a sense of what your experience is.
Right. So the question is, what's the ballpark number of the effort required to implement such a driver? It's kind of difficult to say because I haven't really worked continuously on the driver. I've just implemented parts here and there. But I would say so far maybe I have invested a month or so if I had worked full-time on it. But I feel like to get it really production ready, there's still at least a month or two missing. Just, I don't know. Don't sue me if that doesn't work. All right. If there are no more questions, then thanks for listening and have fun at the conference.